Now, if you want to, let's say, measure speed, I mean, now we know what type of vehicle is going, but we don't know the speed.
But then you know the peaks, so when how far away the peaks are, I guess.
Yeah, I know, but just by looking at this, it's difficult to say at what speed it's going. One thing it is possible, you are correct. Since each type of vehicle has its own signature, and we know, okay, if it's a bus, this will be the typical length.
Okay.
And a bicycle, this is a typical length.
Right.
So, since it is detected as a bicycle, I can look at for how much time this vehicle was there above the loop. And the loop dimension we know. So, it is possible to calculate. We have done that. It was accurate enough.
I have a question. So, before we get into speed, what if, right? So, you have a coil.
Yeah.
Now, what if you have two cars, half of one car is in one coil, this is another coil. Is it something that...
That is very rare, because if you look at the width of a loop, within the, multiple loop, individual loop, if you look, it's only 60 centimeter.
That's not very...
Yeah.
So, even the tires are quite bigger in a car, so it'll...
Yeah, too.
Yeah,
those rare conditions can come, but the probability of happening this is very, very low.
So here you were saying, sorry, you look at the width of the waveform, and you know it's, say, 80 centimeters.
Yeah, and this much time, the vehicle was there above that. Assuming that it's moving at constant velocity.
Right.
So we can find out we know the length of the vehicle, we know the length of the loop, we know how much time it took to pass that loop. So definitely.
So time, how do you measure time?
Yeah, because this waveform is with respect to time actually.
Okay.
Okay. Yes. But the standard way is use two loops and measure, because the loops are designed to use one loop per lane. Correct? One loop per lane. So, and there was no question of identifying what type of vehicle it is, because it's meant for, in a lane, okay, this is a bus lane. So it's a bus. You don't have to think much. So you put two loops, find out how much time it has taken to travel from one loop set to the other loop set.
Yes. This is what the loop, I don't know in India, but it's similar to India. It's just like we've seen two like kind of wires. You go over it and then go over the other one. So it's like some kind of a waste sensors. And then based on that, you can see the...
I think it's a piezo
something. That's it. So, but you're saying now you have two sets of loops.
Yeah. So I will find out what's the time it has taken to move from this loop to the other loop.
Right.
So we have done some tests like that. So as you can see here, this is the time it has taken. So I will get an output from the loop 1 first, or the first set of loop first, and then from the other set of loop. So we can find out, okay, what's the time it has taken to move from. So it's very clear.
So and all you have to do is just put another set of loops.
Yeah.
So that is also a good way to sort of confirm, signatures. Is it the same? And also it shouldn't be too far apart, because sometimes maybe it's too far. The same vehicle go ahead.
Exactly. And you can also find out which way the vehicle is going, which direction it's going. It will stop in set 1 if it's going from, here to here. Correct. So.
And anyway, you have unique signatures anyway. The first tire and the second tire.
Yes. Even without using these details, this is possible. Now, using that, also it is possible. This is another test that we have done. Same vehicle, just going at different speeds. So what you will see here is the time for which it is present above the loop is reducing as I move fast. So that's why you see this a small one, while this is a wider one, and so on.
That's very nice.
Yeah. In fact, we found, calculated the speed, but then to confirm, we have used a reference, laser-based measurement, and then compared also. Well, it was quite accurate.
So I mean, also speaker. Laser is more accurate when on the outside still. And how percent cube?
So I think it was about 2%. The laser itself was, I think, close to 2% or so. And so, yeah.